Okay, should be up and running. I'm going to do the first 18 problems and then the second half of that test. And I'm going to say it and do it quickly. Sine 11 pi over 6. First thing that comes to mind is 12 pi over 6, which is equal to 2 pi, which is equal to 6.28 radius lengths around the circle, which takes me 1 full revolution. I am 1 chunk of 6 less than that. So sine minus 1/2. A lot of folks make sign errors, understandable. See them a lot in the early going. Your job to correct that. My job to start to put the camera where it belongs. All right, so 11 pi over 6, 12 pi over 6, 1 chunk. Pi over 6, 180 divided by 6, 30-degree reference angle. But this is equivalent to the sine of 330 degrees. 1 period of the sine function goes up in the first 90, boom-pity. We're looking for minus 1/2, which is way over here, 330 degrees. Okay. All right, that's that problem. Let me get an eraser. There we go. Got one. All right, next problem. See if I can see it. Cosine of negative 17 pi over 3. Cosine of negative 17 pi over 3. I know the pi over 3's cosines are either plus or minus 1/2. Just mention that to you. Doesn't hurt to know that. So we get rid of that one. Okay, what comes to mind? Minus 18 pi over 3, which is minus 6 pi. Minus 6 pi is once, twice, 3 times around on the circle. So 3 times around in the counter in the clockwise fashion takes me right back here, coterminal. 0 and negative 6 pi are coterminal, and I'm going in this direction. So didn't quite get to negative 18. So therefore pi over 3 60 degrees. So there's your triangle, there's our 1/2, and that's to the right of the y-axis, so it's positive 1/2. That's how you do that problem. Linear function, 7 negative 2. All right, so I got to turn a 7 into a negative 2. Okay, so that's a 7. I got to turn that into a negative 2. So I don't want 7, I don't want negative 2. All right, so you should have done x minus 7 minus 2. Most people are. If you're not, think about it some more. This is where things change. X minus 7 is all about linear change. And when I drop in an 11, I get a linear change of 4. But 4 minus 2 does not take me to 7. I want to get this number to turn into a 7. Sure looks like I better put a 9 here. And so there's your function that satisfies 7 negative 2. You put that in, you should see that come out. And if you put this in, you should see that come out. I don't usually like putting the same number. Did I do that? Yeah, I did. I never in the early going like to have the same number appear as a duplicate, because you're trying to learn how to do it. And the numbers should speak for themselves. But that's that one. So we have a smallest side of 30, 60, 90. I think we know the ratios of a 30, 60, 90. And I want this to be 8. Well, I guess I got to multiply this triangle by 16. And if I do multiply it by 16, not the best drawing, then the hypotenuse becomes 16. 16 times 1/2 is 8. And 16 times root 3 over 2. Well, I know 2 goes into 16. So 8 root 3. You have a memorization sheet now. Do you know what the square root of 3 is? It's helpful to go through the course knowing. I doubt people do at this stage, even though I ask you to memorize. 1.73. So how do you get from 8 to 16? You multiply by 2. How do you get from 16 to 8? You divide by 2. Okay, so there's a nice relationship there. I think we can see the 2 to 1. How do you get 8 to 8 root 3? You multiply by root 3. How do you get from 8, 3 back to 8? You divide by root 3. This shows up on your SATs a lot, by the way. So replay the tape, replay the video, And play it enough times until that makes sense to you. Write a quadratic function through negative 3, 6 as the vertex. All right, so negative 3, 6 is the most important place on that curve because we can express the numerical change from there because it's patternable. So x plus 3 squared plus 6 is the start. Most people got there. So x plus 3 squared is all about area. Plus 6, so we can think of 6 as a unit of area. All right, so how does my area of this x plus 3 times x plus 3 change? How's it changing when I introduce another x value? And the next x value is 11. And we won't even put a number there yet. So let's put 11 in here. Let me make sure. Oh, I misread the numbers here. I'm looking at the linear function. Negative 210. So I got to go back. I got to go back to 210. I didn't have to change that. Right, and that's an x, and over here we got x plus 3 times x plus 3, and that's an area statement. So when I put a 2 in, I think I'm getting an area of 25. And is 25 plus 6 equal to 10? I would say no. So we don't like this number, so I'll divide it out of there. It's gone. What number do I add to 6 to get to 10? That's how you do that problem. In other words, if you went over to 2 from negative 3, this is negative 3, and you go over to, on the number line, to 2, then you've changed by 5 units. But if you square that, you should go up 25 units. 25 units, okay? That's still not drawn well. All right, so let me bring it here. So I started with that, so 25 units might be there, but you didn't go up 25 units. You only went up 4 units. I guess I had to do that there. Yeah, that doesn't look good. But if that's 4 and that's 25ths, then what really happened is you did 4 25ths of the change that occurred. And that's what you multiply by. And that's simply 5 squared. So it's very similar to a linear function through the 2 points. So if you want to just get it right, write the equation of the line, negative 3, 6 to 210, and that's that. You want to turn it into a quadratic? That's all you got to do from a mechanical standpoint. Next problem. 3x minus 4y equals 24, a standard form of the line. So if you didn't write the 2 points that come from a standard form of the line, then you don't know how to work with this. And the way you work with this is to find the x and y intercepts. Let x equal 0, your y intercept's negative 6. Let y equal 0, your x-intercept is 8. So you connect those dots, negative 6, positive 8, and you got the graph. That's standard form. All right. Next, 10x squared minus 20x plus 17. I'll do this 2 ways. The way that most people connect with it is to get the first term, okay, minus b over 2a is equal to positive 20 over 2 times 10. It looks like that's the number 1, the smallest area a square can have. I hope you see that that's tending towards 0. So I want the number 1 to act like that. I got to turn that into that. Well, then if x is 1, I better get rid of it. Now I have a minimum because this is cup shape up. So I've got a minimum. At least the x value I know is 1. All right, so I know that. So I'll put 1 in here. And if you do, you get 10 minus 20 plus 17. And I hope you recognize the signature of the evaluation of this parabola, that negative 2-to-1 ratio exists. So that number is correct. All right, so we put 1 in and we get this, and that's minus 10. I hope you see a little relationship there, plus 17, and that's positive 7. All right, that's how you do it. For those of you who know how to do that, Great, here's a quicker way. All right, so y-axis. I know I'm at 0.17 and I'm decreasing. So I'll put 0.17 here, and I know I'm coming down at 20 to 1. Cup shape up. Okay, so I now know my x is positive, right? So all I have to do is divide 10 into 20, just 2, and cut it in half. So that's how I can get that 1. And if I put a 0 in here, I want to get 17. So when I put 0 in here, I'll get rid of that, because that would all be the same. When I put 0 in here, I get positive 10. Well, what if I don't want positive 10? I get rid of it. What do I want? Positive 17. There's your 7. Okay. And so that would have been this. Now, you're on a test, you want to make sure you got it right. So the thing you do is you go back 1 and you square it. You should go up 1, but we didn't go up 1, we went up 10. Okay, I guess I got to multiply this change by 10. Oh yeah, I did. All right, that's that problem. Nothing's preventing you from replaying this until you get it. That's all up to you. I'm asking this question every single test the rest of the year. Okay, 16 to the minus 1/2. All right, I know the square root of 16 could have been written as 16 to the 1/2. And I know that 16 to the 1/2 is 4. And I know the minus sign is a reciprocal. So 4/1 becomes 1/4. Log base 2, x to the 1/2. I'm really pushing this now. Log base 2 to the what equals 1/2. Well, we just said 16 to the 1/2. Well, let me do it this way. Let's just look at log base 5 of 25 equals 2. Is there another way you can rearrange those numbers? I think so. Okay, I would hope you would say, oh yeah, 5 squared equals 25. All right, so what is 2? It's an exponent. So if that 2 is an exponent, what equals an exponent? I guess a logarithm is an exponent. It's the value of an exponent. Well, that's an exponent. It goes on the base. We just talked about this. So what does x equal? Square root of 2. 2 to the 1/2 is the same as that. Play it over and over and over again until you get it. Next problem. Where are we? X squared minus, going back to algebra 1, x squared minus 2x equals 24. I'm going to graph this. I'm going to rewrite x times x minus 2 because it's helpful. I know when that's equal to 0. I know that's equal to 0 when x is 0 or when x is 2. And I know it's a cup shape up. And I know that there's a 24 as a constant. So there's some x over here that's smaller negative than the, I'll call that my first x. My second x intercepts there, and this is the y-axis, that's further away. So I'm going to get 2 numbers. The bigger one's going to be positive. What did you learn in algebra 1? You learned that length times width equals 0. So I'm going to rewrite this as x squared minus 2x minus 24 equals 0. Because if I can get this to be a product, I can see my answers. So I can see -2, so -6. Positive 4 equals 0. And so that is a rectangle. X plus 6, x minus 4. How do I get rid of that dimension? -6 works. -6 plus 6 is 0. I don't have any width, I don't have any area. So -6 gets me a 0 in this equation. And if I put a 4 in here, 4 minus 4 is 0. 0 times anything is 0. That's what we're trying to see in that line of work. So 2 answers, 6 and -4. Okay. 30 degrees, 3. So then we want y and z. So x is 3. That was a duplicate. I said you didn't have to do it. So 3, but let's do it anyway. All right, and that's 60 degrees. So we're going back 20 minutes on the video. So that's 6 and that's 3 root 3. You remember what root 3 is? Just heard it 10 minutes ago. Maybe this time it was in your head. All right. So is this side longer than that side? Yes. So I'm multiplying 3 times 1.73, which is smaller than 3 times 2. Oh, somebody's calling me. Hang on. Oh, where's my phone? Do you hear it? Such a pretty ringtone. Let's see if I learn how to use it. Hi, Case. Yeah, I thought you called me. Okay, now I'm gonna let you go because I'm videotaping 20 problems in a YouTube video, and now you're part of it. Very good. I'll see you at 4. Bye. Father of the twins, A and B, are now named Parker and Everett. All right, here we go. Next problem. Where are we at? We're at 7 up. So I want to get 7 up. Okay, so I'll get rid of 7 and I'll write up. Put a 7 in, you get up. I don't care what you multiply by. Put a 7 in, you get a multiplication by 0 plus up. Up. All right, now what are we looking for? Perpendicular. Perpendicular is 4x minus 5y equals 20. All right, so therefore 4x equals 5y. 20 doesn't matter. It has nothing to do with rate of change. Could have been 2,000. Who cares? The rate of change is the multiplier. So 4/5 x equals y. Perpendicular to 4/5 is negative 5/4. We demonstrated that in class. I'll do it again. So here's 1, 2 change. Change by 2 for the x's. Change by 1 for the y's. We refer to that as a 2 gets you 1 conversion, just like miles per hour. Hours get you miles. All righty, where was I? Oh, perpendicular. And if you measure that, you go over 1, and lo and behold, look at that, you go down 2. So minus 2 over 1 is the perpendicular to that. Well, sure looks like a pattern to me. So what's perpendicular to 4/5? Minus 5/4. Oh, so your final answer then is minus 5/4 x minus 7 plus up. And I'm sure it's just a coincidence that those numbers go there. Just a coincidence. Probably never happen again. Sarcastic alert. Sarcasm alert, as what was his name? Not gonna remember. All right. Square root function through negative 3/5. Okay. This is square root. What's the smallest that can be? 0. All right, same thing for the area. Smallest area I can get is 0. If I got the smallest area of 0, then the square root of 0 is 0, because 0 times 0 is 0. So I want negative 3 to act like the square root of 0. So when I put it in and I add 3, I get the beginning part of a square root. All right, well, this is where the change occurs. That's where the change occurs. And so we got another x we're going to use. Oh, it goes through 8, 1. 8, 1. Well, when I put 8 in here, I don't know what you get. But when I put 8 in there, I get the square root of 11 plus 5. And I do not think that's equal to 1. So I got to convert the square root of 11 into, how do I get from 5 to 1? I got to go down 4. Well, I think if I divide by the square root of 11, then that cancels, and negative 4 plus 5 is 1. Oh, so I guess that's what I wanted to do. I think there's a pattern emerging here. Of course, you have to think about it. You have to actually give it your critical thought. Hope you do. 4x minus 7, 2x plus 3. Those of you who multiplied this out, I'm sorry, because we just talked about length times width equaling 0. So that's a dimension. That's 4x minus 7. This all comes from rectangles. 2x plus 3 equals 0. We'll find some numbers that make 0 times 0. So when is 2x plus 3 equals 0? Sure looks like negative 3 divided by 2, a couple of inverse operations. When does 4x minus 7 equal 0? Looks like 7/4. Those are the roots of this quadratic. All right, so I'll give you a string of multiplication and see if you can come up with the numbers that work. We'll do 2x squared times x minus 5 cubed times 4x plus 1 times 7x minus 5. Let's do 9x plus 20. And let's do that to the 8th power. And let's set that to 0. So I guess I got length times width times height. And that's cubic. And then I got new dimensions. I don't even know how to draw anything more. Height, I got width, length, width, height. I got to get out of the real world. I got A and B. Any one of those letters, if you put in a number that makes a 0, if I can find the right number that makes a 0, 0 times anything is 0. So I hope you said minus 1/4 for that one. How about this one? You said 5. This one, hope you said 0. This one, hope you said 5/7. That one, pause a little bit. You can be pausing this all the time. Minus 20/9. Once you know what you're looking at, you don't have to work. Now, some folks don't have any retention from the first 2 years of study. This is a chance to study it differently and get some retention. But it's going to require you coming out of every single class, knowing how to do 1 or 2 things you didn't know how to do before you got in there. That's going to take work for folks who need to get some foundation here. All right, 17, 4 to the 2x. And then we got 8 to the x minus 2. And we're trying to find exponential values. Well, you can't talk about exponents unless you got similar bases. So 4 could have been written as 2 to the 2. 8 could have been written as 2 to the 3. This is being raised to the 2x. This is being raised to the x minus 2. If the bases are the same, then the exponential activity has to be the same. This becomes 2 to the 4x. This becomes 2. Be careful here. I'm multiplying something that has 2 parts. I'm going to multiply both parts. 3x minus 6. Therefore, if these are equal amounts, then 4x has to equal 3x minus 6. So therefore, x equals 6. Minus 6, excuse me. All right. Addition of 3x on this side is subtraction of 3x on that side. And I hope you can see why I brought that this way. That's that problem. 18. Let's see how time we got. All right, I can do a few more. All right, 18. 18, 4 cosine x over 2 plus 3. Divided by 3. All right, let's do something we know. Let's do 6 divided by 2 divided by 3. Well, 6 divided by 2 is 3, and 3 divided by 3 is 1. So I could have done that. Knowing that now, I got a feeling that division by 3 could have been written there as well. I'm dividing by 2 and I'm dividing by 3, which means I'm dividing by 6. I hope you see you still get the number 1, tricks of the trade. So this could have been rewritten as a 6. And now I'm putting what in? Where am I? I am 19 pi over 3. All right, so I got 19 pi over 3 for x, and I'm dividing by 2. We just talked about this, right? This division is the same as dividing by 6. And I'll do it a different way. Dividing by 2 is the same as multiplying by 1/2. I still think you should see the 6 from one of those perspectives. 19 pi over 6. It's the 3rd time you've done that one, I think, isn't it? 12 pi over 6 is over here. We got to go another 7. I think we've done this triangle earlier in the test. Did you remember the minus sign? Did you remember the minus sign? What are we looking for? Cosine. Okay, so minus root 3 over 2. So this is 4. Is there more to this problem? Did I write it down? Yeah, there's plus 3 here. Okay, so what does this become? Becomes 4. We did the cosine of this place on the circumference of the circle. It's negative root 3 over 2. I've asked you to memorize Negative root 3 over 2. If you don't know it, look it up. Or put it in your calculator. Okay, I'm not going to tell you anymore. All right, so 4 times negative root 3 over 2 plus 3. Well, that's negative 2 root 3 plus 3. That's a radical, that's an integer. They're not like terms, you can't add them. So that's that one. Maybe I can get this done in 10 minutes. Maybe. I'll keep going. 20. 5 log base 3 of x minus 4 plus 21 equals 11. All right, so I'm going to subtract 21 from 11. That makes negative 10. I'm going to divide negative 10 by 5. That becomes negative 2. I am going to change this to exponential form. This quantity, this exponent. Exponents go on top of bases. So 3 to the negative 2 is going to produce x minus 4. 3 to the negative 2 is 1/9. Subtraction of 4 is addition of 4. And that's your x value, 4 and 1/9. Some people said 37/9. Either's fine with me for a problem like that. Okay. Next problem. Write an exponential function that takes 100 grams. So I'm going to look at the weight of something. Parts of whatever. We'll just call it Y. Y, 100 milligrams of caffeine. Yeah, so that's different than what I was saying before. And it triples it. And it looks like it triples it every 20 hours. So why don't I write caffeine based on time, C of T. Okay, so time, every 20 minutes or seconds, I forgot what it said on the paper, but that's it. Now, the numbers for T that are user-friendly, 0, 20, 40, negative 20 would be like negative 1, 0 is 0, 20 gets me 1, 40 gets me 2. Those numbers are easy to do. 3 to the negative 1, 3 to the 0, 3 to the 1, 3 to the 2. So you're trying to find numbers that work and are easy. That's it. So if we put a 0 in, we get 10 times, 100, excuse me. We get 100 times 3 to the 0. I hope everybody knows that's 100. So if I'm starting a table, 0 gets me 100. No, I think we start. That's a start. Stopwatch, 0. Punch it. All right, we put a 20 in. 20 divided by 20 is 1. 3 to the 1 is 3 times 100, 300. It looks like it tripled to me. Put a 40 in. 40 divided by 20 is 2. 3 squared, 9 times 100, 900. Hope you can see the tripling. All right, so if I start somewhere and I get an amount, 100, next one's 3 times that, 300. Next one's 3 times that, 900. I hope you see how quickly we're climbing. And that's why we don't want the virus in an exponential transmission mode. Population is thinning out though. Only so many people can get sick, so I think the Omicron is on its way down, fortunately. All right, we got, I'm gonna push through this. 3x over 4 minus 4. And maybe I'll stop here because I gotta do some graphs and I got a class coming in. 3x over 4, what the heck am I? My 5x minus 4/5. I hope everybody can see that 1 plus 2 equals 3. I hope everybody can see how I'm getting 10 plus 20 equals 30. All right, so I guess if I multiply everything times each term, I get equality. So obviously I multiplied that by 10, all right, just as an example. Now 1 could have been written as 5 divided by 5. I could do 10 times 5 is 50 divided by 5 is 10, but it's easier to say 5 goes into 10 twice, and 2 times 5 is 10. Easier to do that. So it would be nice if I could pick a number here that 4 and 5 divide into. And if I do, what was a hard problem becomes an easy problem. So I'm going to pick 20. 20 times 3x is 60x divided by 4 is 15x. It's a whole lot easier to do 4 into 20 is 5 times 3x to get that. That's what I'm going to do. 5 times 3x is 15x. 4 times 20 is 80. 20 times 5 is 100x. And 5 goes into 24 times -4 is minus 16. I don't like dividing by negatives. So I'm going to move addition of 15x to this side as subtraction. So that's 85x. Subtraction of 16 is addition of 16 right here. So that's minus 64, I believe. Multiplication by 85 is division by 85. That's your answer. Right, and I think that takes me to problem 21. I'll write that somewhere. And I'm going to stop there. I'm going to upload this. And then I'll do the second half later today. I probably won't get to it 5:30, 6 o'clock. All right, so there's a little study. Math help tonight at 7. Ciao.